So we want to now be able to derive log functions. And while there is a proof for it, it may be difficult without doing it with integration. So for now, you understand that you've got log functions, and if you want to derive a log of x, then you've been told that it's 1 over x. Now, you might not know why it's 1 over x specifically, but you can probably agree that it's a reasonable kind of, well, like you don't know it's 1 over x, but like it kind of fits the properties is what we're kind of trying to say here. In the sense that, well, a log graph looks like this. And we understand that the derivative is the rate of change of, you know, y as x changes, yes?
Yeah.
And therefore, it's kind of like the gradient of the tangent in a way. And so if we don't focus on the specific number and just focus on the properties of the derivative, you can probably see that for your log curve, and zoom's moving a lines around, so they're not really all that great, but you get the point.
Yep.
We can kind of see that our gradients are positive or what? Or negative?
It's positive.
So our gradients are positive. And as x increases, does the, you know, gradient go up or down?
It's go down.
Now, approach as x goes to infinity, m goes down, but does it ever go negative?
No.
So while 1 over x is most certainly not the only function that sort of fits this criteria, not at all. You know, it could be a constant times this, for example. It could be 1 over x, or, you know, it could be 1 over x squared. It could be 1 over x, you know, power 4, or, you know, or any 1 over x to the power of anything, really, because x is positive, so we don't even need to worry about being negative. So while 1 over x is most definitely not the only function that fits this criteria, you can probably be reasonably satisfied for now that at least we can't say it's wrong. We can't say it's wrong.
Yep.
Yep. And look, we'll leave the proof till later if we do it at all, but the derivative of log x is 1 over x. Now that's not strictly true in the same way that the derivative of an, you know, remember when I said the derivative of a to the power of x, we said by definition was a constant times a to the power of x, right?
Yeah.
So, you know, the derivative of a to the power of x was not a to the power of x, but rather the derivative of, you know, e to the power of x for a particular value of e is e to the power of x. So k equals 1. Yeah?
Yeah.
So that's what we said when we did exponentials. Now, when we do logs, a very similar thing happens. So I won't draw out the curve because I think you're more than comfortable with it, but you understand that a log graph, I mean, I'll draw one out, but I'll just rub it up very quickly. So for different bases, you understand that there's different sort of steepness, right?
Yeah.
And so clearly the gradients aren't equal, depending on the base. So again, you'll have this issue where, you know, depending on the base, you'll get different values. So actually, what we'll need to rely on is the fact that this is log base e of x is 1 over x by definition.
Yep.
So the derivative of log, or, you know, x, log base e of x is 1 over x. Okay. Now, just applying your general rules then, what do you think is the derivative of log x plus b?
So it's a over x. Oh, no, it's a over ax plus b.
Good. And really, I mean, while you might remember that as a separate rule, it really is just using the chain rule, right?
Yes.
And so similarly, if you derive, log of fx, what is that going to equal?
It's f dash x over fx.
Indeed. And this is a pretty important result, but, as, even though it's an important result, it really is just your chain rule.
Yes.
Now, so these things hopefully, allow you to sort of do your derivatives without any sort of trouble. That's really shouldn't, I don't imagine you'll have any trouble with that.
Yes.
Now, do you know how to do log base b of x, where, b is not equal to e?
Yeah, so it's 1 over x in b.
Okay, that's true. Do you understand why?
Nope.
Okay, so that one you just memorized the formula.
Yeah.
So you shouldn't do that. And in an exam you need to show working. So you've got the right answer. Your answer is correct. And when you memorize the formula, are you saying your teacher just told you the formula and that was it?
Like teacher kind of explained to us, like it's e to the power x in a, right? I can't really remember. It's just
Well, no, that's for exponential.
oh.
That's the explanation for exponential, which we also did. But now we're trying to explain the log. So it's a similar, but not exactly the same. So the same sort of idea. We kind of we will need to rely on log base e, but we don't have log base e. So how do we make it into log base e?
Oh, so it's log x over log b.
Yeah. And then if you like, it's 1 over log b, which is a constant because it's a constant, right? Times the derivative of log x, and that's why it's just going to be 1 over log b times x.
Yeah, that makes sense.
So while that is, the answer, you shouldn't just memorize it because you will most definitely need to, show the working for this.
Yeah.
This one you will need to show working. And as you can see, it is quite similar to what we did with, a to the power of x by changing it to base e, right? We do need to rely on base e.
Yeah.
Good. Do you have any problems with that?
Nope.
Okay. Well, just throwing, I don't imagine you'll have much trouble with this, but, just doing some very basic questions to start with. So what would that equal?
It it's 2x over x squared.
So that would be?
2 over x.
Okay. Now, do you find that curious?
No.
I mean, you don't? Well, if it's 2 over x, then what's the derivative of, if you're saying it's 2 over x, then what's the derivative of log x times 2?
Oh, it's 2 over x as well.
So how can those two be the same?
Right. Oh, because you can move the power to in front of the equation.
Exactly. So, you haven't done anything wrong, but you might also want to notice that, feel free to do it this way, no problem.
Yeah.
But what we're also saying is that an alternative way is to use your log rules. So if you're deriving log of x squared, and obviously this is very simple, so who cares? But you could alternatively, without deriving, treat this as derivative of 2 log x using your log rules, which is then 2 times 1 over x, which is 2 over x. Does that make sense?
Yeah.
Now, feel free to completely do whichever way you want as questions become more difficult, but just recognize that there are the options to do it directly with chain rule, and if you're good at that, there's not really a problem anyway. But there's also the option to use your log rules.
Yeah.
And if you're good at both, really, I wouldn't really necessarily find one necessarily easier than the other, but some people find one way much easier than the other way. So it's personal choice here. All right. Yeah. And in your exercises, you'll get some which will ask you specifically to work by log rules. So, you can exercise your sort of log rules sort of thing there. But, so for example, if I did like this. So let's do it one way. How do we do it?
Like first find the derivative of this fraction.
Yep. How do you do that?
It's x plus 1 minus x for minus x over x plus 1 to the power 2.
Mm-hmm.
Oh, and then just times x plus 1 over x.
Okay. So basically it's the chain rule, right? So derive the log, that gives you that part. Then you need to derive the inside, which needs the quotient rule, which is that, all right? Hopefully you can see that's going to be, just 1 over x plus 1 all squared, and you're going to times x plus 1 over x. So that quickly simplifies down to safe space. So that gives me, 1 over x plus 1, right?
Yes.
So not too hard, because, you're just using chain rule and quotient rule, one after the other. Now, some students might find that difficult, but obviously, it's not as hard as you think, and obviously you can just do it directly. But let's do it the alternative way. Now, if we do it alternatively, how would we do it?
Log x minus log x plus 1.
So this will be asking you to find the derivative of log x minus log of x plus 1, which is then?
1 over x minus 1 over x plus 1.
Yeah. And then, do you have a particular preference for this particular question?
Yeah, actually, I normally do the first one, like
Yeah.
the first way, but it's more
Wait, which way? The blue way or the black way?
the black way.
Yeah, that's fine. I mean, I'm happy for you to do that. Like, it doesn't really matter. As I said, it's just, it doesn't matter. Unless the question made you do it one way, as long as you're comfortable with it and you appear to be, that's fine. It's really not a problem. Yeah. So obviously, we could do sort of products as well, right? And chain them up and so on and so on and so on. All right. So, do one final question. I don't imagine you'll have trouble with any of this at all, but all right, how do we do this?
So we can first find the derivative of the second part. Right?
Yep.
So it's log x to the power 3 minus log x plus 1. So it's 3x to the
Okay,
power.
wait. Are you doing that separately? Are you saying you're doing that separately for the moment?
Yeah.
Okay, all right. So we'll call that, I don't know, u. All right. So you're saying u dash is?
So it's 3x to the 3x squared over x to the power 3 minus
Like that?
yeah.
Okay, yeah. Okay, yeah. I see why you're doing it. Okay, so you're using the log rules for this one, it seems. Okay.
And then it's 1 over x plus 1.
So, all right, so just quickly, so if u equals log of x cubed over x plus 1, so I wasn't sure how you were doing it. It appears that you're doing the log rules for this case.
Yeah.
So, and then of course, then u dash would then just be, 3x squared over x cubed minus 1 over x plus 1. And then that would of course give us 3 over x minus 1 of x plus 1. And then we can maybe simplify that a bit. So that's going to be 3x plus 3 minus x, so 2x plus 3 over x plus 1. Save a bit of space. That hopefully is correct. And then if that's the derivative of that, then how do we do this?
And then use the product rule.
Yeah, so go ahead.
So it's x squared times 2x plus 3 over x times x plus 1. And then plus 2x times x to the power 3 over x plus 1.
Ooh, you want to say that again?
Oh. Wait. Oh, so it's log x to the power 3 over x plus 1.
Yeah, don't leave out the log,
Yeah.
right? Good. Make sense?
Yeah.
Good. So that's basically really all I mean, you know, as I said, the crux of the issue was chain rule, product rule, quotient rule, and we obviously spent a bit of time on that. So you appear to know that quite well, which is excellent. And so you can see, you know, there's nothing else to say here, really, right? So if we're still only doing derivatives only for now, then it's time to move on to trig. Yep.
Yep.
So derivative of trig functions.